Hello techies, hope everyone is doing good. Today I'm gonna sharing my interview experience in Amazon Web Services for the position Cloud Engineer. So let's get started. Interview is like one screening round which is of half an hour. After that there will be four non-elimination round which is of 1 hour each, and it is not like if you have given a round really bad they are gonna reject you. You have to give all the four rounds. So in the end, all the four interviewers will sit on a round table and decide if it is okay to move your profile forward or not. So let's get started with the screening round. In the screening round, what the interviewer has asked to me is like basic networking, like TCP IP model, what is TCP and UDP protocols. In AWS, what is EC2 instances, S3 bucket, and in Linux, how you can check the load and the memory and the network statistics, and the OS, what is the boot process. So something similar to that. I'm gonna discussing on each and every round. So currently in this video, in the video is all about the first round, which is of networking. And guys, please don't think like the first round is gonna be networking. Any round can come anytime because it is dependent on the interviewer availability. So we're gonna discuss that. So first round, for me it was like networking, coding, operating system, and leadership principle, which we are gonna deciding in my further video interviews, like part 1, part 2, and part 3. In this video we are gonna discussing about the screening round and the first round, which is networking. In the screening round, they basically asked me some basic questions on the operating system, networking, and the AWS. So the questions on the AWS is like what are the type of load balancers? So the classic load balancer, application load balancer, network load balancers. And in networking they have asked me what is public and private IP addresses. So basically public IP addresses that you can access anywhere from the world, and it is can be accessible on the internet. And private IP address is basically local to you, and it can be accessible from the local network. And there are different IP of class ranges like type A, type B, type C that you can check on the internet. After that, some basic questions on the Linux, which is like how we can check load and memory. So load you can check from the top uptime, and the three value which you see in the top, like for 1, 5, and 10 minutes, that you can tell. And for the memory part, you can say like I can check it from the free or the top command itself. So here I'm not gonna focusing on the screening round because they are really basic questions, and if you find any difficulty in reading and understanding these things, you can just comment in this video, and I'm gonna make a separate video on these basic question which can cover all those stuffs. Okay, so the first round I received the call for my first round, which is for the networking. So we are gonna discussing this round in depth, and each and everything they have asked to me. The first question they have asked me is like how Traceroute works. Traceroute is just a network diagnostic tool. It helps to identify what are the network routes in between a host, and also tells like what is the time it has taken to reach that particular route or the hop. So uh, before explaining all the details about how Traceroute works, I need to explain what is an IP header and what are all the details on it. So let's just move to this diagram. So in this diagram you see in the network layer of TCP ID model, every transmission which happens between a client and a host, there will be some packets, and that packet had some details which is necessary to transmit over a unreliable channel, which is internet. So if here we see their source IP address and destination IP address, which is like the client and the destination IP address. Also there are other details like protocol data and what is the total length of the particular header. all those details. But here we need to focus on this TTL part. So the TTL part is called time to live. Basically it is not like the life of the packet. So here don't confuse with the word like the full form, which is time to live. Basically it is just a number which tells like the number of hops this packet can take. The reason behind the TTL flag is that if I'm gonna accessing any website, then I am not sure when it is gonna reach and how many hops it's gonna take. So the internet authority has assigned some particular value like 20 or 30, that the after these number of hops just say it is not reachable, because we don't want like our packet keeps on going around the globe and across each and every router, and I am not sure when it gonna reach. So it just time out, or just after these many hops just discard the packet and return it to the client and say like it is not reachable. So this is the property of the TTL. Here in our question, Traceroute use this flag and helps us to identify all these details. So first started with the let's start with the TTL value 1. So Traceroute set the TTL value as 1 in his first packet. When it reaches the first router, so the router say it has received one packet, and it decrements the value of TTL by -1. So if we see for each and every hop, the TTL will gonna decremented by 1, and until and unless it reaches 0. When it reaches 0, that means the destination is unreachable. Now what happens? Now the traceroute will set the TTL as 2. When it has set the TTL as 2, then it will go to my first router, which is 1.1, and it decrement the value by 1. Now the TTL has become 1. Now it can still go to the next router, and it has one more life also. So it has gone to the next router. In the next router, reads the TTL value, and see it decrement the value, and now it becomes 0. Now it say like I cannot move forward this packet because the TTL has become 0. Now it will send a reply back to the client by sending his all details, which is the IP address and when it has received the packet. So same thing, Traceroute will do this step until and unless it reaches the destination. So it is gonna increase all the thing by 1 2 3 4 5 6 7 until and unless it reaches the destination of that particular google.com. So there is a bonus question here, like if you see the asterisk here, so what does that mean here? So sometimes like in some routers, what happens if they receive some values, they actually doesn't return those values. It is a particular configuration in the router itself which you can set, and by reaching this router, they don't want to identify identify himself, like who they are and what are the details of it. So sometimes you can get this asterisk values. So in the end it will reach the router and you will get all the details. So this is the how the traceroute works. And the second question which the interviewer has asked, I'm gonna tell you. Second question they have asked me is like what protocol Traceroute uses to send these packets. So Traceroute can use a different mechanism to send these particular packets, which can be ICMP, UDP and TCP itself. So that you can check the manual pages, and there is some command line parameter where you have to mention what protocol you need to send a message. So here I know about the ICMP protocol which is used here. So the third question they asked me is like what is how if you have used the ICMP protocol, then what the details has been sent in the headers. So basically in the TCP header, when I am requesting any details from a particular router, we attach an ICMP echo request messages, so that ICMP echo message is read by the router, and when the TTL becomes 0, it send a reply back, which is called ICMP TTL exceeded. So in that TTL exceeded packet, it mentions the IP address of the particular browser and when it has received that particular packet. So this is the counter question, or the third question has been asked on this particular topic, which I think has gone like for 25 to 30 minutes. Like there was a board and I had explained all the details about it. And so this is everything about the Traceroute. If you have any doubts, you can ask me in the comments and I can clear it up. So next, some question they have asked me about the DNS, TCP IP and three-way handshake. So let's just discuss about the DNS. Let's first talk about the DNS system. For that we can take an example like example.com. So in example.com, if I want to browse the example.com, then I need IP address of example.com. Then how we are gonna get it? First, what happened? The system, like if I am typing this in my browser, or maybe I am using a curl command, and first it will gonna check my DNS cache, like in my cache if the domain to IP mapping is there or not. After that, it is gonna checking etc host file. If it is also not there, then it is gonna check my etcresolve.conf. So in etcresolve.conf we have name servers defined there, like name servers are basically our DNS resolver, which is kind of a database. In these database we have all the details of the domain names. Domain to IP name mappings are there. After that, our machine will send a DNS request, which is a request to that particular DNS resolver. Then that DNS resolver gonna search his database, and if that particular domain to IP mapping is found in its database, then it will gonna return the IP address of that particular domain, which is example.com. But let's just say if it not able to find it, then what happens? So the query which has been sent by our system is called recursive query. So you can remember this, what is like what it is called. After that, like if it is not able to be found in our DNS resolver, what happens? Our DNS resolver do is like it search the root server. So root server is basically our dot. So if I talk about the whole full form of my website or domain, it is called www.example.com dot. So dot is my root server. So root server has all the details of all the name server of the top level domains. So my top level domains are com, edu, in, au. So all those domains are called top level domains, and dot is called the root server. So my DNS resolver will ask the name server of com. So root server will give me the details of com, and after that it will go to the com name server. Then the com name server will tell me the details of the example.com. So because com should have all the details of example.com, because it is a sub part of it. Then it will go to the name server of example.com. So a name server of example.com has the IP address of example.com. Then it will give the details or IP address to the DNS resolver. So the answer which you are getting from this particular server is called authoritative name server, where original details has been stored on that name server. So this is called authoritative server. If let's just say if I have get the answer from the this DNS resolver, then I will say it is a non-authoritative name server, because the main server where like when first the first domain, when the domain has been created, then the IP address first stored in this name server. After that, it get replicated in all the domain servers. So this is my authoritative name server, and this is my non-authoritative name servers. After that, what all the communication which I have told here, like 2 3 4 5 6 7 7 8, this is called iterative query, which has been sent by the DNS resolver. After that, I get the answer, like this is the IP address, and I can able to browse it on the I can able to browse it in the browser or the from the curl. Now let's talk about the TCP three-way handshake. First, moving to this diagram, I want to talk about more about the TCP, like what is TCP. Basically, TCP is a protocol which helps us to which it helps in reliable transmission of our packets. Basically, over the internet, if I am sending a packet, it can get lost, or maybe it has some errors which I was not able to detect it. And if I am sending a message, I don't know if the other person has received or not. So if we have these kind of problems over the internet, so to cope up with these problems, we establish a protocol which is called TCP. So TCP helps in error checking, the retransmission, and the acknowledgement of a particular packet. So this is a TCP protocol, that's why we use it. So let's just discuss about the three-way handshake. So how we can establish a secure and reliable channel to a particular host. So not secure, we can do it securely, but currently it's just reliable. Now let's just say if we have a computer A and computer B, and now I want to connect to computer B. So first, A will send a TCP packet in which we set the flag, the SYN flag, as value. Let's just say we set the sequence value as 100. So if we talk about this flag, when we are talking about the IP header, there are different sets of flag, and we can set that SYN value here. And there is also a header where it says sequence number. So sequence number basically it tells what is the sequence of that particular packet, because there will be a lot of packets, and the packets, if there is a large file, it is divided in number of packets, and it should have some sequencing, like this is the first part, second part, and third part. So the sequence is here, it is starting with 100, and we are just telling SYN, like we want to connect to you. So this is the detail which is sent over the network, and computer B received it. So when the B received it, it set the flag SYN and ACK. ACK is synchronized and acknowledgement. So now the sequence number can be anything. It can be it has been set by the computer B, but when it is sending a reply back to the computer A, the acknowledgement is the increment of the sequence number of that particular SYN packet which has been sent by the computer A. So here if you see, the sequence was 100. When it is sending back the acknowledgement of 100th packet, it is 101. So, and this sequence is of computer B, which can be anything. After that, when it is reply back the answer of the acknowledgement of that particular sequence, then it says SYN, it will reply back SYN and acknowledgement received. So now what happens, it will send back the acknowledgement of the sequence packet of 300 and increment it by 1, so it will become 301, and the sequence number of the acknowledgement packet of this thing, and it will become the sequence 101. This is the whole TCP connection establishment protocol here, which you can explain to the interviewer. The last question interviewer asked me about is the TCP IP layers, and I have explained him all the 7 layers. Uh, in the end, like only 5 to 10 minutes were left, and I have explained a small overview about each and every layer, and they have not bothered to ask me them into depths. So let's just get started. The physical layer, so the physical layer is just nothing, you can say when you connect a power cord, so the data which has been transferred in between the physical lines, your cable is the physical media, is called your physical layer, the data encoding part. After that it comes the data link layer. In the data link layer, you see we have MAC addresses or the Ethernet frames, like for each and every device there are MAC address, and to communicate it over the particular host or a device we have MAC addresses, so that part comes here. After that it comes the network layer. So in network layer, we have the addressing part, so where to send it. So the source address and destination IP addresses, which we have talked it about earlier, the IP addresses, the IP header. So the next thing comes the transport layer. So in transport layer, like when all this thing has been done, where how you wanna send it, like how you want to send it reliably or unreliably. So the TCP is a reliable source of sending the packet, which support all the details which I have mentioned it earlier, and UDP is not reliable, it just send the packet and forget it. Next comes the session layer. The session layer is just to manage the sessions between two application processes. After that it comes the presentation layer. It actually has some function to compress and encrypt the data which we are sending. And lastly comes the application layer. So application layer is basically your the protocol, the HTTP protocol, FTP protocol, and the things which you are using for your this stuff like browser and the email. So I have written all the details like HTTP and FTP. It comes here. So this is a small detail which you can mention to the interview, and if you want to go into the more detail, you can just go to the Wikipedia and learn about all those things, all those stuff. And if you have any doubt in understanding anything about each layer, then you can just post and comment in the videos. So one thing you just keep in mind, you from this model just remember what are the protocols has been used in each and every layer, and you are good to go. So I think these are the all the questions have been asked to me, and I thought I have done pretty well. So I have moved to the next round. So I think we can wrap up this video here, and for the next round I'm gonna make a new video which you can read and prepare for. If you have any interview, you can prepare from it. So the all the question which I have told here has been asked to me, and for in this interview I have selected. So thank you everyone for watching this video. Hope you enjoyed it, and if you have any comments and doubt, just comment it. Thank you, and goodbye.